This is Unit 7, Video 3, Dilutions. So we've learned how to work with molarity. Molarity is the way we're going to represent solutions in the laboratory. We have to be able to dilute solutions. We're going to add water, typically if water is the solvent, and take a very concentrated solution and make it dilute. We want to know how much to add or what molarity will end up with, all those kind of things. So the dilution formula is fairly simple. We know molarity times volume equals moles. So if I take the initial conditions, molarity, and multiply by the volume of those conditions, I'll have the moles. Well, after I'm done, the moles doesn't change. Anytime you dilute, all you're adding is the solvent. So the moles dissolved is still the same. It's just changed concentration because there's more solvent. So the second condition, molarity and volume, should also be the same number of moles. So here we have moles of solute in condition 1 equal to moles of solute in condition 2. Okay, that's going to be our dilution. So we typically say M1V1 equals M2V2. Now M1V1 equals M2V2 is only valid if we have the same solute in both cases. This is not valid in stoichiometry. Okay, very important because in stoichiometry we're changing substances. We'll come back to that later, but it is important to be aware of that. Okay, we got a couple of problems here. We want to know the new concentration if 50 milliliters of a 2.25 molar hydrochloric acid solution is diluted to 300 milliliters. So think about what's happening here. We've got a solution, and we've got 50 milliliters with a certain amount of HCl in it. Now we're going to add some water and raise the volume to 300 milliliters. Okay, at that point the HCl has spread out uniformly. It's a homogeneous solution, so it's spread out uniformly. So we have a new concentration. So let's use our formula. Now, one of the things you want to be aware of, most of these problems are going to say volume of a molarity. That of is connecting one condition. So this is V1, this is M1. I have a new volume. That's going to be V2, and my unknown is M2. So let's plug it in. We've got molarity 1, which is 2.25 molar. Volume 1, which is 0.0500 liters. So I've converted my volume into liters because molarity is in liters. That's going to be equal to my new molarity, that's my unknown, times my new volume, 0.300 liters. Divide by 0.3 and we'll get the new molarity, M2, equals 0.375 molar. So, in summary, I've diluted the solution. I took 50 milliliters of a more concentrated solution, added water to make 300. Now notice, I didn't add 300. I added enough water to make 300 milliliters. So this is the total volume of the solution. When I'm done, my solution concentration is 0.375 molar. All right, here's another one. We're going to calculate volume. What volume of A? So this is going to be V2, M2. I can go ahead and notice them, even before I read the whole thing. 15 molar acetic acid solution is needed to produce 200 milliliters of a 3 molar solution. So this is going to be V1 and M1. It doesn't really matter which is 1 and 2, as long as they're connected. That of is very important. Okay, so we've got M1V1 equals M2V2. So let's take M1, which is 3 molar, multiply it by 0.2 liters, set it equal to 15 molar times our unknown, V2. Divide both sides by the 15, and we'll have the volume that needs to be added, which is 0.040 liters, or 40 milliliters. So I'm going to take 40 milliliters of this concentrated solution, very concentrated solution, and then dilute to 200 milliliters, and I'll have a much diluter 3 molar solution.